When we consider electronic business or e-commerce or e-business, it's inevitable we must look at technology and look at the basics of technology that underpin the whole system. Some of the terms and expressions may not be familiar to you, and some of the relationships between certain components and certain protocols may not be familiar to you. But it's important we go through these and get some understanding of what it is that makes e-business possible. So let's start with the technology basics. For a start, the internet links computers throughout the world. That's what the internet is. It's an enormous network of computers right across the world, all linked together. Their connections are through servers and through each other and on throughout the world. So the internet is global. It's a vast number of computers linked together. It uses rules. The rules are known as protocols. So in computer language, when we talk about a protocol, we're talking about rules. The rules with which the computers connect to each other, or the rules with which the computers operate within that environment. And these protocols have been developed over the years to enable the exchange of data between computers, which presumably is the whole idea. The computers are connected together for some purpose, and that purpose originally was to exchange data, and now it's for more overt commercial purposes. We have online shops and online buying and selling, and we have trading online, but we also still have the use of the network for the exchange of large amounts of data. But it's also used for communications and entertainment and so on. The internet operates through links, and these are created by use of wires. There could be fiber optic connections, there could even be radio waves. But one thing for sure, the internet is a set of computers connected together, and the connections must enable the flow of information, the flow of data, the flow of contacts between one computer and the next. So these links could be telephone wires, which was traditionally used, or fiber optics, which are much faster and give a better service, but more expensive. Or it could be radio waves. Sometimes people live in areas where it's not economic to have a wired connection, or it's not feasible to have a wired connection. So they may use telephones or radio waves. The internet is constantly evolving as new technologies become available. So it's an ever shifting feast. The internet is constantly changing, constantly being upgraded. There are new ways of making connections, new ways of using the facilities of the internet. So it's not a static environment. Increasingly, the net is encroaching on traditional routes of business life, or traditional forms of business life. Not long back, the use of the internet in business was seen as avant-garde. It was very modern, it was very risky, it was very advanced. But nowadays, it's taken for granted almost. It provides remote conferencing facilities and emails and databases and other facilities. And it's used widely for marketing purposes and public relations. In fact, the internet now is almost an indispensable part of business life. Intranets, by contrast, are internal to the organizations. So an intranet it's like a local internet. An intranet is inside the organization. It's got its own server, it's got its own links. But it doesn't have to have a connection to the internet. It may be just internal to the organization, but it's very useful within the organization. It helps the flow of ideas and communications within the organization. It disseminates information about the business plan or about particular products or stock levels or areas of concern, whatever. It enables efficient communications within the organization. Computers within organizations are usually networked together so that employees may communicate with each other. It almost eliminates paper. There's no need for paper and printing. And it saves time on the internal communication system. Simply leave a message for someone, leave it on the system. And when they log on, they receive their message and they respond. I suppose there is an onus on the users to make sure they do log on. People who use intranets should log on a frequent basis to see what's happening, what's required of them, what communications there are, what's happening within the organization. Extranets, by contrast, are networked that connects businesses. These could be between businesses. An extranet is, if you like, it's like an intranet, except it's got a link to another business, and it may be connected to the other business's intranet. So an extranet is businesses coming together and sharing information. They are linked together. They share technology to the internet, but generally speaking, they're not open to the public. They are internal, so that the public can't get access to them. And that's the way it should be. It's their business. They need to protect their business and protect the flow of information and commercial secrets. Now, how the internet works? Well, the internet operates by taking the data entered and then breaking it into packets. So when we send data, the internet breaks it up into packages, into packets, and then sends the packets down the wire. And then at the end, it reassembles the packets back into the full product, what was sent initially. So the packets are broken up into parts, sent off separately, and then reassembled at the end. The packets are transmitted along the best available routes to the destination computer. The packets have to make a journey on the internet, so they have to find the best routes, the most efficient routes to get there. And when they get there, they must be reassembled back together to form the message. They may travel along different routes. They may be switched routes. They may switch routes from one to another. They may move past some nodes on the internet. They may bypass some servers that are busy and skip on to the next one. The idea is to try and get there as efficiently as possible. And then, of course, as I said, to be reassembled, all the parts put back together to make a meaningful message. The software used for packet switching on the internet is the communications protocol called Transmission Control Protocol stroke Internet Protocol. So Transmission Control Protocol stroke Internet Protocol, TCPIP. So this software is what enables the communications flow to take place. It's designed to route the data through the system and to ensure that it's assembled at the end. So the data can be sent a very long way, but it uses a variety of channels. It could use wire, cable, fiber optic, satellite connection. It could use corporate networks, including microwave. It's very flexible. The whole idea is the message needs to be sent from A to B, and the system needs to work out how best to get the message there and to make it a meaningful message when it's there, and also one which has integrity. The message sent is the message received. Now, the infrastructure of the internet, well, the physical part of the internet is owned by many companies who provide services for free. So when we think about the structure of the internet, we have different companies who provide services, sometimes in return for advertising, but we have email services from Google and from Microsoft, and we have free space for to store files online, and we have lots of facilities which are given to us free. I suppose the downside is that we have to tolerate advertisements and be exposed to repetitive advertising and so on. A good example is YouTube. To see a YouTube video, we often have to sit through some seconds of a trailer for an advertisement, presumably something we didn't want to see. But if you want to see the video, you have to tolerate that. Generally, most people connect to an internet service provider, which is known as an ISP. Usually this connection is made across a telephone line. So for most of us, excuse me, for most of us we would connect to the internet using an ISP. We would pay the ISP a sum of money, usually every month, in exchange for access to their servers. And we use a telephone line to make the connection, generally speaking. Although having said that, broadband connections are becoming more and more available. So there's more and more use of fiber optics, at least for part of the journey. Perhaps the last few hundred yards maybe still by telephone wire. But that's how we normally gain access. We subscribe to an internet service provider. The ISP has a permanent connection to larger host computers, who in turn carry the data packages via high-speed connections. This is called the backbone of the internet. The backbone is these very powerful servers who have very fast connections between them. So what we need to do is we need to get our package, or our packet, through our ISP, our internet service provider, and get it onto the backbone so it travels fast, and then it comes off and it's routed down slower networks until it's delivered. But we're talking sometimes a matter of seconds by the time we send an email to the time somebody receives it. It could be very fast indeed. But the backbone of the internet is this very fast connection between very powerful computers using very high-speed connectors like fiber optics. This is known sometimes as the information superhighway. That's what we mean by the superhighway. We mean this very fast connection that exists between certain parts of the internet. Now, connecting to the internet, well, there are 4 ways in which businesses and individuals may connect to the internet. The ways selected will depend on the cost and benefits given the required level of service required. So what we choose, or how we choose to connect to the internet, depends on what we're going to do, what we want to do with the connection, what type of information we wish to access, how fast we need the connection to be. First of all, on-demand direct line connections. Well, on-demand direct line connection to the internet may be either via a modem or a LAN. A LAN is a local area network. We may have facility to have a LAN connection to our house, so we just plug our desktop computer or our laptop or whatever into a LAN. It's very unusual, but it is possible technically. Generally speaking, what we have is a modem. A modem connects to the telephone wire. It enables us still to use telephones in our dwellings where we live, but we also have now the facility to use data. Generally speaking, we can't get very high speeds on the internet using this facility, but it's cheap and it's quite common. Ethernet connections are communications standards for transmitting data between computers. So Ethernet is when we use cables to connect the computers, and these are communication standards for transmitting data between computers. Now, on-demand terminal connections, well, this involves connecting to a machine that is already connected directly to the internet and therefore is part of the internet. So a terminal connection is we find a computer that's already connected to the internet. It's permanently connected to the internet. Let's say it's got a very fast connection, and we can connect our machine, our desktop computer or whatever, we can connect that to it. And of course many people can connect through it and share the speed of that machine. If there are many users and they're all demanding videos and sound and internet conferencing, then as you can imagine the connection will be pretty slow. The first machine only requires a modem and modern communication software to enable it to connect to a terminal machine and hence to the internet. So generally speaking, it's a clever way of getting a connection, but it's really only used in situations where it's economic to have the terminal. For example, in a large office building, office block, or within certain companies where there is considerable demand for this type of facility. Offline connection, well, this involves downloading and storing information on a hard disk that is therefore available to the user at any time. Not widely used, but becoming increasingly popular in parts of the world where there is no internet connection, there is no internet infrastructure. So it may be possible to download large amounts of information, store them on hard disks and make them available, for example, in schools in areas where there is no internet. So the students may benefit from access to the material. In fact, it may be possible to see what the students want through the links that they're clicking and download follow-up pages the next time it connects to a satellite. Download the pages via satellite link and store them on a hard drive and make them available to students. So it is becoming useful in some parts of the world. Special software enables the computer to download the material and also send emails written offline, and they are sent automatically once the connection is established to the internet. So a lot of the functionality of the internet can still be used, except it's not immediate. It's stored on a hard drive, and when the system is reconnected, perhaps via satellite link, reconnected to the internet, the emails are sent, the information is downloaded, and life goes on. Now, supported connection methods. Well, there are more complicated methods of connection. They may use Ethernet or serial connections using SLIP. The SLIP is the Serial Line Internet Protocol. That's a standard that enables the TCPIP packets, the ones I talked about earlier, of information to be sent between different types of computers. There's also PPP, which is point-to-point protocol. This is a protocol that provides a method of transmitting packets over serial point-to-point links. So there are different protocols, different ways of connecting. The TCPIP, which is a way of routing the information, breaking it into packets and perhaps reassembling it at the end. It's been around for a long time, and it's a standard way of working. The serial line internet protocol is a development of that, but it's still based on TCPIP, and the PPP is the point-to-point protocol, which again is just a variation. As you would expect with the internet, there are constantly proposals to update some of the protocols, update some of the routines to try and get more out of what we've already got, out of the existing system. So we try to get more out of it. We try to squeeze more speed, more and better connectivity. We try to gain advantages that perhaps were not obvious in the past. So that's the way of technological progress, after all. These are the PPP and so on. These are standards for telephone modem communications between a user's personal computer and an internet service provider. So it's how we connect our personal computer to the ISP, and we may use PPP and so on. So, as I said, they're all constantly on the lookout for improvements that can be made to the existing system to generate more speed, better reliability, and perhaps also more security. A protocol is a set of traffic rules, procedures and standards designed to allow the transmission of data and information. That's what a protocol is. We are constantly talking about protocols. Well, a protocol is simply a set of rules. It's how machines talk to each other. They must establish links. They must agree to talk. They must have something in common. That something in common is the software that it runs, which enables the communications to take place. Now, for successful transmissions, these rules have to be accepted. So if they're not accepted, then the transmission, the data will not flow. Across the internet, there can only be one protocol. Otherwise, computers would not connect to each other. So if we think about it, we have the internet with millions and billions of computers. They must all agree to talk, and they must all agree to the same standards. Otherwise, it can't happen. Otherwise, there will be a break in the transmission. If two of the servers are using different software, different protocols, that's a break. The data can't jump between the two. Data may be exchanged in duplex mode, two-way communications. For example, like a telephone conversation. When we talk on the telephone with someone, both people may speak at the same time. It's not a very nice thing to happen, but it could be. Or it could be somebody is making a point and the other person interjects, and so that we can speak and hear. It's two-way. We can speak and hear almost simultaneously, not almost simultaneously. Some networks may use one-way communications called simplex, the simplex mode of transmission. For example, the electronic data interchange, which is used in business, EDI, this can be a simple one-way operations. One company sends information to the other. Well, the traffic is one way. Sometimes traffic is two ways. If we have a video conference with someone, the information is flowing both ways, flowing from one person to the other and back. Both of them are speaking and dealing with the video conference. So there are some which are simplex. In most cases, transmission occurs in only one direction at a time. This is called half duplex mode. In the past, when people used radios to communicate, widespread use of radios, sometimes they would make a call to someone else, and when they were finished speaking, they would say over. That meant they had now stopped speaking, and when the person listening heard the word over, they knew it was their turn to speak. So now the data could flow in the opposite direction, and when they'd finished speaking, they would say over, and so on. That's because the data could not flow in both directions at the same time. The TCPIP protocol, this is the most basic protocol on the internet. It allows the users to send and receive messages, for example, email. And the TCP/IP is essential for the use of emails. It's essential. It's an essential part of the internet. It's essential that it's there so as to enable the flow of, for example, messages. But we can also find information and interact with other businesses. It's all TCP/IP. We can consult specific sites and home pages. We can find the information, click on them, and the hyperlink will take us to that particular home page. And we can also download software, again using the TCP/IP protocol. So that particular set of rules is very important in the use of the internet, and it's been around for a long time. Other protocols have also become popular on the internet. As I mentioned earlier, these include point-to-point protocol, PPP, and serial line internet protocol, the SLIP one. And also there's one called the post office protocol, POP. POP is widely used for email purposes. These additional protocols have enabled more sophisticated operations to develop on the internet. The more protocols there are, I suppose, the more the internet can do. But the sender and the receiver must have the same protocols. They must understand the rules, and they must be able to accept the messages. In the early days of the internet, computers were connected in LANs, local area networks. There were few point-to-point links. In fact, right at the start, there were, well, it must have started with just 2 computers connected via a wire, and tried to get the 2 computers to send messages and receive messages. So LANs, very basic LANs, come into existence because of the lack of standard or protocol. When protocols are agreed and the software that runs the protocols are put on the machines and they are properly configured, then in a sense any computer may contact any other computer, and providing the protocols are there and accepted, a communications link may be established. If the computers are running different protocols, then there is no link. There's a break at that point. The information cannot flow further. PPP was developed to provide that standard we're talking about, and to manage IP addresses at the host server for the internet. So PPP was a way of providing a standard, and the protocols that were used conformed to standards that were agreed, but also the PPP managed the IP addresses, the internet protocol addresses that are so necessary to send information around the network. Logically, information sent must be sent to an address. When we click on a hyperlink, the hyperlink takes us to a particular IP address. We don't recognize it as an IP address. It's not in code. It's not sets of numbers anymore, although they are in the background. We use a domain name server, and goes through a different server, domain name server, which converts the code, the numbers, into a name that we'd recognize. So there's a certain set of numbers taken together, which will be the BBC, for example. But if I want to search for the news, I may enter bbc.co.uk. In that case, the domain name server has translated the numbers into something I would recognize and use. PPP permits a computer connected to a server via a serial link, such as a modem, to become an actual mode on the internet. So it opens up possibilities, the possibilities of using our computers as parts of the internet itself. If our computers are properly configured, we could add our computer to the stream of ways in which data can be sent over the internet, and our computer would then become a server, and it's a way in which data can flow. It enables anyone to connect to the internet and to send, receive and store emails or browse the web. That's what the PPP does. It gives us the flexibility to access the internet, access sites, to send information, to send emails, to send communications, and to receive and store emails and browse the web. PPP was developed by internet service providers running commercial sites to the internet. It enables service provider developers to develop an automatic login and provide the user with a password and automatic dialing of a telephone number to gain access to the internet. So PPP is it goes back quite a bit in time, but it automated the connections. It enabled the use of passwords and authentication systems to make sure that there was secure communications, and it was able to route the information from one machine to another machine, and that other machine, as I have said many times, may be at the other end of the world. The SLIP connection connects the user to the internet and allows the same use of the internet as PPP, but SLIP allows the users to send and receive files using only the TCPIP protocol. So the SLIP connection is a little restricted because the TCPIP is not designed for security. It was designed in the early days of the internet when we didn't seem to have as many problems with hacking and stealing data and so on. So, but it's there and it's used. Most people use TCP/IP. That's how we connect. That's how we use the internet. So that is the most basic protocol. That's the one that establishes the links, and everything else sits on top of TCP/IP. POP2 allows users to log onto electronic hosts and download messages to their computer and upload messages to the host for delivery over the network. So the post office protocol, POP2, this enables us to go to a server and collect our emails. That's how we download our emails. If we're using Microsoft Outlook, the application which is a part of Microsoft Office, we would download our emails from the server. They reside on our laptops or on our desktops, and we read them and we respond to them and send them back from the desktop or from the laptop. And this would be the use of POP2. In business or on service provider server, there is a facility to receive all incoming email messages. A POP email program downloads the emails from the POP server to the local computer. So some servers are designed so that when we go to a designated server, we may download our emails We download them and we read them at our leisure. We may read them offline and respond to them offline. And then the next time we connect the computer, they're sent. That system has been challenged widely by online email, and indeed online email services such as Google, Hotmail, and the many others, Yahoo, many others that exist, who store the emails on a server in the cloud. And we simply access our emails, read them, they're stored in the cloud, and respond to them. And the downside of that is, of course, that we must be connected when we're dealing with our emails and writing our emails and so on. Whereas with the POP system, we may download them and be offline. This is a short talk about protocols, about the rules that govern the use of the internet and the different types of rules and connections that there are. It's a very big topic, and there'll be more sessions on this area of technology later in separate classes. But that's all I'm going to deal with at the moment. I'm going to leave it at that, and as usual say thank you for watching.